Welcome everyone to the EasyPower Tuesday Refresher webinar series. My name is Jim Chastain, an applications engineer here at EasyPower. I'm afraid I oversold this topic with the way I described the title, Relay Coordination. Not replacing conventional coordination techniques, but I am proposing that it's a good way to get started and give you additional information about your system. And that's we'll get into that here shortly. So welcome everyone, and as we are in the habit of doing, we like to start with a poll question, get a little response from the audience, no obligation or liability. And the first poll question is, how often do you use EasyPower Sequence of Events feature? So appreciate some feedback, just indicate your position one way or the other. No liability or obligation. We do supply a certificate of attendance for everyone that's attended the webinar, and you'll receive that via email probably within the week. So it looks like we're close to a quorum. Here's how folks have weighed in. Good. All right, thank you for participating. And the second question is, how often do you have projects with multiple relays in series? This is a little trickier, and I'm curious to know what the experience level is. Again, it turns out we've ran across a study with heavy concentration of relays in series. So that's kind of what prompted this topic. And hopefully you'll get some benefit from my exposure to it. All right, looks like we got a quorum. Some folks have weighed in. So higher than I expected. Great. Thank you for participating. Let's jump into the details here. So again, the agenda is going to be a little bit more focused on the utilization of the tools, some emphasis on relay modeling, because I think we kind of undershoot there, underachieve as far as explaining some of the details. And then get into more discussion about what I consider to be a technique, utilizing sequence of events. By all means, it's not a recommendation, and it's again, a display of multiple tool features. Some parts may be useful, some not. So I leave that up to you to make the decision. Now, sequence of events is a feature that's built into EasyPower that, again, is not that well understood or regarded, but I find it's extremely valuable in a number of applications. For instance, one that jumped out at me early on was when you have, say, like renewable energy designs with photovoltaic sources that don't turn off on a fault, and people end up trying to adjust their incident energy by a relay on the utility and not understanding why it didn't change. And sequence of events just very quickly pointed out that the problem was there was no control over the PV contribution. So there's a lot of places where it's a good place to start. And hopefully, as you kind of see me walk through this example, you get a little bit more feel for that. It is possible to create a sequence of events for just one bus or the entire system. And often when I talk about this is not a way to do the TCC coordination, but it is a way to estimate how much time you're going to have to spend based upon how many protective devices seem to be out of whack. And especially if you're doing a study on an existing system where presumably it was coordinated at one point in time, sequence of events is a nice way to check system coordination without a whole lot of extra effort. So again, there's multiple places where it can be picked up and used. So again, I'm going to be jumping into this complex system that has multiple transformers and relays, a fair amount of redundancy. Coordination is a complicated task at best. And what you're going to see is what I felt was a pretty good first pass at coordination, at least for one value. And then clearly, once you see what I've got going on, it will be necessary to go back and check overlapping zones for relays to make sure that the slope or there's not some miscoordination other than the current that we checked. Okay, so let's jump into EasyPower and see how this goes. All right, so one of the things I want to do is to illustrate some features that are very useful. For starters, the find element, I'm going to go back to database edit. And let's kind of go ahead and save what I got. The find element is this little binocular series up here, and it's a good way to start locating devices if you have some specific reference. In my case, I know there's a bus that is important as far as the loading because it's on the largest bus load that we have in the system. And it's bus 7C. Now I'm going to be coming back and forth to this display, so I'm going to save it, save the zoom and pan parameters in EasyPower under a named view called bus 7. And you'll see why that helps here in a minute. But what it allows me to do is to jump back and forth from any reference point that I want to start with without a whole lot of scanning and scrolling around. So here's bus 7C. I want to go into coordination. First thing I want to do is a sequence of event report for bus 7C. So I've isolated on the bus, go into coordination, fault the bus. Now before I do this, under my PDC options, the right-hand column I've created or checked, create sequence of events report. So at the same time I do this little, the icon on the second row here is made available to me when I'm in this condition. It not only demonstrates the sequence of events on the one line, but it gives me a report that tells me something. So when this bus trips, this breaker will trip in 16 milliseconds, breaker, the relay. This relay will trip in 16 milliseconds. And so you can see I have miscoordination because apparently the relays haven't been set up. Well, again, when I did that report, it shows up under my list of windows. If I bring it up, it shows me all the relays that are in series with this particular bus upstream. and none of them look like they're in good shape as far as coordination. So this is where I'm going to be focusing, at least for the short term, to see if I can't get some first pass parameters. Now what I'm going to do is export this to Excel, and it looks something like this. And then I'm going to insert a trip time column that this is where I'm expecting to have this relay for this particular current level allow for about a 300 millisecond separation, considering we have breakers opening and different voltages. So coordination looks like it's about 300 milliseconds per each phase, each step. So again, that's just an arbitrary number. Probably minimum would be 200 milliseconds. Let's stay with this. So the first thing I want to look at is relay R4308. So let's close this puppy. And again, if this bus faults, this relay is the first in place. Now I'm just going to show the plot the TCC just so we can talk about it and the setup of the relay itself. Okay, first of all, I'm not going to be saving this, and I don't want to look at ground. So I can see why there's a 16 millisecond fault on the momentary current of 5800 amps, because there's an instantaneous trip set quite a bit lower than that. If I open up the relay icon, I can see the setup. We're looking at the phase trip. Now I want to point out that even though the tool makes a pretty good estimation of what breaker it's going to be activating, if I left this blank, it would still probably find BH4. My recommendation is make sure you've designated this, especially in a relay-rich environment, because there can be misdirection. Same is true for the CT, especially if you have multiple functions on the same relay and multiple CTs, you could get cross-pollination between ground. In addition, instead of just using numbers, we're using the mnemonics phase and ground for each of my functions. So if I go look at settings for the phase element, this is an issue with the instantaneous set where it is, because it's going to be tripping pretty fast and at relatively low current. So there's two things I'm going to do that I may want to go back and check later on. I'm going to disable instantaneous. I want to go back to my specification and make sure I'm not clipping the TCC plot. Now, once I get things coordinated, I may want to go in and clip, especially at interrupt current, but for now I'm going to leave it undone. So let's see how that applies to my plot. Okay, it allows me to bring it. And what I'm talking about, we still get the same trip time, but we're opening up the section above it to allow other relays to be put into place for coordination purposes. So overall, this is not a bad place to start, and reserve the right to make changes as we go forward. Yeah, so Roger's asking, is the trip time on the one line excluding the breaker? The answer is yes. And the plot on the TCC, what the sequence of events shows and what the one line shows is the response that we've generated with the TCC of the relay. So it ignores what the breaker opening time is. All right, I'm going to close this, not save it because I don't want to clutter up my directory. And as I scroll up, I see the next relay in line is this one. And if I go back and look at my printout, relay 71531, I want to be set up for about a 650 millisecond trip at the interrupt rating. Oh, that's another thing I wanted to point out. So let's plot this. Okay, do the same setup. I'm going to ignore ground for right now. Now I've set this relay for a tick mark. I'll open the dialog box. In the settings page, specification page, in the spreadsheet here, there's check boxes that generate the tick mark. So traditionally things are in momentary current, but because I'm doing such a gap in my coordination, I really want to look at 30 cycle. So if I check that and apply it, it shows me my 30 cycle, and I want this to be tripping at 650 milliseconds. So if I zoom in a little bit, 650 is going to be right about here. So I'm going to take my tick mark up and look at the bottom of the cursor coordinates. So there's 575, 600 milliseconds. And I don't want that to be instantaneous. So now I can't move the instantaneous setting beyond that point. So let's go back and make an adjustment. All right, so there's no clipping. I'm not going to set my instantaneous on. All right, now keep in mind that I've got the coordination that I want, but I'm on clipping, which may interfere with my coordination display. It doesn't interfere with coordination necessarily. Okay, so let's leave that. And then go to the next relay. I'm not going to save the changes at the plot. Okay, this I want the interrupting current to be 900 milliseconds. So let's set this up. "900 milliseconds is right up there. Okay, 915. So I need to change clipping, or rather the instantaneous here on this one as well. So I'm not clipping, and I want to take off instantaneous. Now, there may be a reason. Instantaneous is problematic in that it may interfere with coordination downstream. So once I get this set up, I may want to go back and set an instantaneous, for instance, to protect this cable. But for now, I'm coordinating with this. I like the way that looks. Kind of get the idea of what's going on So I'm going to go back to just see if I'm making any progress. I'm going to go back to bus 7, pick out a single bus, fault it, and look at sequence of events. Now I can see I've coordinated that. Let's look at my, so you can see I'm gradually working up the line. Does this make sense? It, um, again, I'm literally just coordinating for a single current. And in this case, it's 30 cycle current. And there's no telling what's going on with the curvature of the relay trip curve away from that. That's why ultimately I need to respond or compare TCC curves in overlapping regions. So in this case, I also have the need to protect the transformer with this relay up here. So let's pick it up, plot the TCC, reduce some of the clutter. And in this case now I don't want to have a trip below the inrush. Here's my symmetrical 30 cycle current, and I want this to be at 1.2 seconds. So 1.2 is going to be up here somewhere. It's 1.16. Looking at the bottom of the screen, 1.2. Now it's not letting me pull this up. And that's one of the things, one of the questions that came up is, can smart PDC do the same thing? The answer is it can't change the range on the relay. So here we've got a pickup setting and a time dial that are affecting my ability to change that range. So let's see what I can do. Okay, just a nudge on the time dial brought this up. I still have protection for the transformer, and I can still, if I need to, when I coordinate with the next breaker up, I can still adjust this and keep my coordination as well as better protection on the transformer, or better bandwidth on the transformer. Okay, so that kind of explains the technique. Let me show you what I'm going for. Let's go back to bus 7, pick a single bus, fault it, look at my windows. So at this point, I've adjusted 3 relays, and here's one that turned out to be 1.87 instead of 1.2, but I have coordination, at least at this current level, and it's pretty easy to go back now and compare the curves for each pair of relays. Any questions about this? It's easy to do this, and frankly, I don't want to minimize the value now of going back and comparing adjacent TCC curves. For instance, now that these are coordinated, I want to plot them and make sure they're not crossing either above or below. It would take a little bit of a tweak on one or the other, but for the most part, it looks pretty neat. Okay, anybody as impressed with this as I am? Sorry. I thought it was a pretty clever way to kind of get a first pass at coordinating individual relays and then going back and dressing it up for my whole system once I've cleared the deck a little bit. For instance, if I want to put on the next relay up, which was that one we just did, hold down Control, select the relay to include it. Now, this is where instantaneous comes in. Let's turn it off the ground. And it'll be clipped. If I turn on 30 cycle clipping, these will be clipped at this same level. Okay. I was impressed by this capability. And again, it's not replacing conventional TCC. I think it gives a little bit more expedience to the experience. So at the very least, you may want to consider using sequence of events as a check of coordination, especially on a system that you know has been initially coordinated at some point in time by just selecting a downstream load and looking at the report. I also encourage use of named views if you're going to be going back and forth or multiple access in a very large system. I really like what EasyPower has done with the find system, with the find capabilities, because there's a fair amount of ordering and sorting that can be done. For instance, if I come back here and I want to find the next breaker up, the next relay up, I go down and look for the relays. And just type in the next couple of letters. It tells me where to find it. 715. It takes me right there. Very useful, and especially on a big system, it can save a whole lot of zooming and panning. Pretty much for load protection, you want to start at the load and then coordinate as you work your way up, which is pretty much what I was trying to do here. On transformer protection, you need to start at the top and make sure your primary protection. In fact, that's the one place when you know the maximum loading on a transformer, that's a convenient place to use instantaneous trip in a relay, because you don't want any current above that's going to be an internal fault. So again, use it sparingly, but using it too much will contradict coordination efficiency. So that's all I had for today. I appreciate you attending. Be sure to check easypower.com for webinar listings. We have, for the first time in a while, we have an Arc Flash workshop in December. You may also want to check, I don't know how many people realize that we offer a no-cost power start session for any new user of the tools as long as the maintenance is current. And this is basically an overview of a system that you've drawn and a critique of your utilization of the tool mechanics. It's not an engineering review, but it can be very useful in getting someone up to speed if they're a new user. Oh, this is a question. As long as I'm reading it correctly, with EasyPower, is it possible to evaluate logic's selectivity between relay and blocking signals in and out? I'm not sure what you're asking, but it depends on what you mean by blocking signals. For instance, one of the issues on this particular system was generator protection, in which case you need to use a restricted setting on voltage. At low voltage, I know I have a fault, and so I'd want to trip lower because the generator can produce actually more current, higher current under load, normal load. So we're showing here an unrestrained trip level where we're protecting the cable and the decrement curve of the generator. But when there's a fault, in other words, we're unrestrained. When there's normal current, we're restrained. When the voltage falls below a certain point, we limit the amount of current that the generator can put out at that point. So whether or not that answers the question, I don't know. Thank you, everyone, for attending. We'll talk to you in a couple weeks. Have a good day.